Good afternoon and welcome to Webinar Wednesday. Today we are joined by GE Healthcare Senior Product Manager Jean-Michel Gard, Sabih Zaman, Executive of Product Management for US and Canada, and Chris Clawson, GM for Unite Shared Services US and Canada. Webinar Wednesday, we would like to thank GE Healthcare for its participation. GE Healthcare is a leading global medical technology, pharmaceutical diagnostics and digital solutions innovator, dedicated to providing integrated solutions, services and data analytics to help make hospitals more efficient, therapies more precise and patients happier and healthier. Serving patients and providers for more than 100 years, GE Healthcare is advancing personalised, connected and compassionate care while simplifying the patient's journey across the care pathway. For more information, you can visit gehealthcare.com/services. Now, just a quick reminder about our Fall MD Expo. We're headed to the Mohegan Sun Casino and Resort in Connecticut from October the 8th to the 10th. So please join us for 3 days of education, networking and the latest advances in medical technology products and services. For more information and registration details, please visit mdexposhow.com. I'd also like you to mark your calendars for our HTM Mixer, which is being held at the Marriott Resort Griffin Gate, Lexington in Kentucky from November the 15th and 16th. Now, our Mixer is a slightly modified, smaller, shorter duration and less crowded event that still provides valuable continuing education, networking and vendor engagement opportunities. And again, for more information and registration details, please visit htmmixer.com. Now, today's webinar is eligible for 1 CE credit from the ACI, and you can obtain your CE certificate by completing the post-webinar survey. The survey will be emailed 1 hour after the completion of today's webinar, and you must complete the survey to receive your 1 CE credit. You'll be able to download the certificate directly from your computer once the survey is submitted. And if you have any questions, you can reach us at webinar@mdpublishing.com. We'll be wrapping up today's presentation with a live Q&A, so please submit your questions anytime using the questions feature on the webinar dashboard. Now, as I mentioned earlier, our presenters today are Jean-Michel Gard, Sabih Zaman and Chris Clawson, and they will be discussing powering the future of service delivery with AI. So over to you, gentlemen.
Thank you very much, Linda. Appreciate it. Thank you, everyone, for attending our TechNation webinar today. We're really excited to share with you our Powering the Future of Service Delivery with AI recorded presentation from the AMI Exchange in Phoenix on June 16th, earlier this year. Since this is a recording, we encourage all participants who have questions about the content to go ahead and put in their chat windows the questions they might have for us. We might be able to respond during the session via chat, or we'll answer it live. Let me start by introducing myself and my colleagues from GE Healthcare who will be participating in the session today. So my name's Sabih Zaman. I lead our product management team for GE Healthcare service in US and Canada. I've been with GE Healthcare for over 27 years and closely involved in driving customer solutions for the last 12. A lot of those have involved in digital technologies, including artificial intelligence and predictive analytics. And so it's really exciting to be able to share that knowledge with you. Jean-Michel Gard, who isn't able to join right now due to technical difficulties, has been a pioneer in this field for over 30 years since the start of our innovations of connecting equipment, and really is the technical brain behind this as well. John, over to you, Chris.
Thanks, Sabih. My name is Chris Clawson. I'm the General Manager for Unite Shared Services at GE Healthcare in the United States. And really what my role is within GE is to serve on the front line. My team serves on the front line with our customers in designing solutions within their healthcare environment to enable technologies that really do drive the outcomes that our partners are looking for from their technology. So day to day, my team is listening for and trying to understand the unique challenges that technology provides in their space in order to impact patient access and ensure that your devices are ready to go when you need them.
Thank you very much, Chris. With that, Linda, let's go ahead and start the presentation.
Okay, good morning, everyone. Welcome to AMI Day 3 or 4, depending on what day you got here. My name is Sabih Zaman, and I'll be your presenter for today. My co-presenter, Jean-Michel Gard, unfortunately had a last-minute medical incident come up, and he was advised not to fly. So unfortunately, he's not going to be with us. But we will have Chris, who's helping answer questions at the end if anything comes up. Good to see some familiar faces from previous days, so welcome to you. So we'll be talking about powering the future of service delivery with artificial intelligence. Now, this is building on a presentation we had previously, and we've been talking about how predictive analytics and AI are really part of the way healthcare technology is moving and how it impacts HTMs. And hopefully with some specific examples we'll be sharing today, we'll make that even further clear. So Jean-Michel Gard is our technical product manager for predictive services for GE Healthcare. He's based out of France, and he's been involved in predictive services since the beginning of connecting medical devices, like since the late 80s even. Early broadband type of work when we were still doing dial-up modems. He's been involved with it since then. So sorry to not have him here. He always has great anecdotes and things to relate to. Myself, I've been involved with GE Healthcare for 27 years now. First 9 were in product development and engineering, then moved to the real world, to the field, where I had to really have work with customers for about 10 years. But then moved back to services in the last 7 years, both for global, for ultrasound and patient care solutions, but now specifically in the US and Canada. And also having had an engineering background and having lived with customers and seeing how these capabilities are really improving, hopefully sharing some of those and how we're really bringing them to life. So our learning objectives for today are, first of all, it's going to be a recap for many of you who have been in the other sessions about how is patch management important, cybersecurity, how is AI really changing things. So that's obviously part of it. But also we're going to go further in how IoT in general and remote capabilities have been changing the way things are working. Most importantly, though, some of the feedback we got was, this is really vague. It's very abstract. How do we actually use it in our organizations? So we wanted this year to make it more specific with examples of how we're using it and how we are partnering with some organizations on that, and how we actually would like to challenge the industry to go that direction, to make sure that we all can capitalize on remote capabilities as much as possible, but also add predictive services. Then also some of the questions we get is, how is it included now in requests for proposals? How is it included in equipment management selection or lifecycle management? We would like to share some of our thoughts on that. And Jean-Michel, having been involved with this since the dawn of when we started implementing it, we thought we would use our position here to say, where do we think the industry is going? So this is something that we work carefully with marketing to separate out what's commercial claims versus where we think it's going, and share those with you. And that's really the power of the dialogue we found so beneficial in the last few years. So, and these are Jean-Michel's slides. I'm going to do my best representation of them. So we're in a stage where we think of it as the fourth world revolution. Now, what do we mean by fourth world revolution? Well, those who know Alan Turing, some of the individual, you might have heard about the Turing test of being able to detect whether it's a machine or a human. Alan Turing said at some time we should expect the machine to take control. And so where do we come to the fourth revolution? The first would be, you could say, starting with steam power. So locomotives really changed the world. It changed the US. It brought railroads across the country. Many continents had the Industrial Revolution powered by steam power. You had mining industries moving goods across the country, moving livestock. It also powered industries where you were able to move machinery and agriculture across the nation. The second would be when electrification began. And of course, electricity in itself is only half the battle. As we know in the HTM world, distribution, getting it to the end customer is a big part of it. So electrification is getting us there. And if you think back, it's not that long ago, unfortunately, 1870. How much has changed? Where you were able to bring light into houses and then also bring them into companies. Of course, the one we're living in now is the IT revolution, which didn't actually just begin with the internet. One could say it was brought to the homes and companies in the 80s, but back as early as the early computing power is really what helped us get there. And a lot of the backbone of our own imaging technology is driven by this as well. All the digital imaging is only capable because of this. We've got more power in our cell phone now than the first space shuttles had in the 80s. But now we're in the fourth revolution, which we feel began actually back in 2009. It didn't begin today, now where we're using ChatGPT and large language models. It actually began when you started using data science. And we started putting together information and saying, how can we predict what's going on? Now, what does that mean to us in healthcare? This is a bit of a recap for many of you. But the beginning of it would be when you had, for example, remote patient monitoring. You have customers who are using virtual ICUs. You don't have enough ICU docs and nurses, so how are we using telemedicine? Further beyond that, you've heard about how people are using it for care pathway development. Doctors are using it to make sure that specific oncology practices are used, getting all the data from different care pathway treatments that have been done to say which one's most effective. Pharma is using it to see which proteins are able to target certain drugs. Which drugs are able to target certain ailments, and then test them out. But then also in our homes and individual bases, we're using chatbots. I know my wife loves using the internet for all sorts of ailments and say, maybe I have this, maybe I have that. But now with chat, you unfortunately see way too many of those even coming up. But then what does it impact us? Now those are all ambiguous. We know computer-aided diagnostics, the second reads for mammos, those are happening 20 years ago. That didn't just begin with AI, right? But now it's able to identify which types of tumors might be malignant and which types of cancer. So all of that is there. But in the HTM space, that's still vague. We're not sitting there doing the reads. We're helping them. So we want to talk about how it's helping us. So you might have already started seeing patient scheduling getting automated, staff scheduling getting automated based on which techs show up more on time or which ones seem to be able to work better after hours versus weekends. So that type of stuff is there. But again, what's impacting us are the last three. And we're going to talk about how we're able to look at parts planning, inventory management. That's us, right? More specific to me and what's linked to the parts planning is the predictive services that tells you when you need the parts. And the part which actually we cannot forget about with IoT, with AI, is the whole cybersecurity angle of it now. It gets so much easier for folks to try to hack in, and all of these predictive services fall apart if we don't have secure backgrounds on that, which is, again, necessary for everyone who's connecting devices. So the link between healthcare industry and HTM organizations. So I shared the high level before. Now let's go into a little bit more detail. So this one we talked about just a second ago. Of course, AI has come into healthcare. AI is being used to create funny images for greeting cards or birthday cards, what have you. But beyond that, AI is obviously something that healthcare organizations are embracing. It's now becoming part of your equipment purchase plans, like how many AI modules are available in this new ultrasound. When I was working in the ultrasound team, they have examples of a doctor is always making these 5 measurements in week 29. Why don't we automate that and then suggest to the customer it's there? That's a cool feature. It saves you minutes each time, especially when you have, for example, IVF procedures and then measuring the size of follicles. Why not automate? Those are really cool things, but how does it impact us? So when we think about HTM and where we're going, we're seeing that as it's becoming part of equipment selection, the predictive service is not necessarily there yet, but it should be. So that's where, as an OEM, we want to help set the stage of where that is, and again, collaborate, because all of these things need the industry to move there. It can't just be one person. So that's where we'll go into more detail. Some companies are starting to introduce this, obviously larger imaging beginning with, but also organizations are starting to ask, and we've seen this numerous times. You've probably, for those of you who are practitioners or looking at equipment selection, where's patch management? How is the remote capability included in this product? What is your uptime requirement? We see this as going in that direction, that our predictive service is included or not. That's where we feel the benefit to the patients at the end of the day, and the clinicians will come into the HTMs, the more and more we have that. And with that, then you not only have the key purchasing criteria created that way, we also have then the selection of the products around it. Here's the pages as well. Sorry, my colleague is having to peer around the corner, so I wanted to give him the slides. But then predictive services powered by AI, this is really the topping of the cake for us. So as we see teams getting more and more empowered, it's important for us, and this is a challenge even within GE, how do we make sure that our own field service engineers, A, know about the technology, and then B, trust it? How do they know that this is not something really putting them out of a job, but it's actually helping them expand their efficiencies? Those are the challenges we have, which is the human factor element of it. One of the very interesting presentations yesterday was about the human factors in designing the product, but also the adoption is very critical. How do you make sure people trust it and know that the outcome will be successful? This is really the big challenge for us as well, and we'll share some very interesting anecdotes of how we thought something would be very well accepted, but it was actually the very opposite. So we're having to relook beyond the technology into the implementation. And then at the end of the day, what are the specific goals and metrics for you? We're going to talk a little bit about some of those and how we feel it will help us keep continuing. So we're going to talk a little bit, again, this isn't a sales plug of the journey we have, but it's very important from the context of the elements of AI that we have. So our first digital imaging product started coming out in the 80s. And if you think about what was available there, the images were created, put onto some form of media, very difficult because you had only media which had a few megabytes at most to save an image. Printing things out, not very efficient. But where was the world of remote diagnostics there? Well, basically it wasn't there. You only knew to call the OEM when the scanner stopped working. And it was already too late. And no, you didn't have redundant systems available. So what would that be in the world of predictive analytics? It's like your car, but you don't even have a fuel gauge. You're driving it, and all of a sudden, like how would people do it before? They would knock the side of the gas tank. Does it sound like it has enough? Sure, it's probably enough, but then you didn't know. That's where we were before. Where we took it, though, with proactive diagnostics, and this started getting introduced in 2006 or so, when we started having broadband connectivity really prevalent, is you now started to see your first fuel gauge there. It said, yes, you've done 1,000 scans. On average, your tube might only last 2,000, so you're okay. But it didn't take into account you're a pediatric facility. It didn't take into account you're doing full body scans and you're running that X-ray tube really hard versus very light. It wasn't very smart. So what would this be? This is your fuel gauge that you now have. Now what it did give us is you did start getting some unplanned downtime. And the theme you'll keep hearing about is unplanned downtime. We know there will be downtime eventually, but how much can we make it unplanned versus planned is the key part. So we wanted to go to a world of planned downtime where we work with your teams, you work with the OEMs, you work with scheduling to say when can we go into. So avoiding the unplanned downtime to the world of planned. And this started introducing a 16% reduction in unplanned downtime. And the reason I mention this is that we've been working on these types of things for a while, even before the buzz of AI became what it is and with machine data, because even as early as 2018, we introduced our first features like TubeWatch. Now, TubeWatch was looking at a tube, and it said individuals running their tube are going to be running them at different speeds, running them at different intensities, different kV, different MA. We also started finding that environmental conditions became very different. The number of times we got called in because the system stopped working on Monday was amazing, and we found it's because someone was turning off the air conditioning on the weekend to save power, and when they turned it on Monday morning, it took time for the temperature to come up, but the system was getting hot very soon. So those types of environmental factors weren't being taken into account when you just look at a fuel gauge. So how do you pull in the environmental conditions into that? So it started with TubeWatch, then we had OnWatch Predict for MR. And so now we're in a world of you have your car, but your car has not only got a fuel gauge, it's like your cars today which say your range is roughly this much, or your oil change will need to be after a certain number of miles because it's based on your driving pattern versus mine. Again, not to, my wife is a much better driver than me, but the fuel efficiency she gets is higher because she doesn't accelerate as fast. She probably doesn't drive as fast. So this is, again, the same analogy here that you shouldn't have to replace your tube just every 2 years. If you're taking care of your tube versus someone else, why should you have that higher expense? And that's really where we want to drive this discussion. And the goal is, again, eliminating all unplanned downtime. So what are some specific metrics we're using that we would encourage you to think about? Let's look at some of those. So first of all, how was it before connectivity? How was it before we had some of these predictive services? Of course, when you don't have connectivity, you can't have your system generating a service record. It's not possible if you're not connected. But now we're actually generating about 50% of our service record on large imaging equipment automatically. And that's because the systems are reporting back something's going on. But again, a human needs to be there to identify what's going on. So where do we go beyond that? So automated notifications, again, you're not connected, you can't get any, but now we've got automated notifications. Remote fix is something that initially had a ton of resistance. Like, why are you fixing my system remotely? Why are you remotely connecting into my system? Well, if we can do that, the same way you might have broadband at home and then they remotely are able to reset it for you, it's the same thing here. We found roughly a third of our issues either are user errors or could be solved with a reboot or some type of small patch. So if we can fix things remotely, why wouldn't we all be happy for that? But again, only with the power of having these predictive services and being able to push data out is this possible. So our remote fix rates now, and it depends on whether it's a smaller ultrasound or a large PET, is over 50%. And then the areas where we're still getting better but not completely there is the planned repair labor. So this is our unplanned downtime versus planned. So we're now 20% better on having the planned labor. Again, not there yet at 80%, 75, but much better at 20%. The area also that's important for us is, and I didn't ask in the beginning, we'll ask later on, how many of you are running shops? I see the gentleman here is from UNC, so you're running the shop there. You don't want the engineer coming and saying, hi, Tim, well, I'm here to fix your problem, but oops, I didn't bring that part. Let me come back tomorrow. And he comes back, oops, I brought the wrong part again. I mean, that multiple visit scenario really is huge for you, and Tim's not happy when that happens. So we're really measuring ourselves on how many times can we get it fixed right the first time, less than one visit. And then lastly, the unplanned downtime is something we take seriously. Now, I looked at this and I said, are we happy about it? It's still not great, but if this is able to reduce our unplanned downtime 22%, that's huge, but again, not where we want to go, and we're not where we want to take our customers. We want to get there much faster. We want to get there better. Now, how specifically, and these are some numbers we shared last year, but then a technology and development we had which was launched already last year, is for MR on-watch predict. Now we have CT on-watch predict, and what does that do? What does it cover? Last year in the MR example we shared, it's not just your magnet, it's your coil, your environmental, it's your patient table. We're going to talk a little bit about how we've introduced that for CT, and we'll be coming out as, again, the technology is in development, and we've shared on this on the roadmap last year. First is this looking at your image chain. So it's not, again, your tube is part of it, but your image chain is your console, your computer, your other elements you have related to putting the processing together, your control boards, your detector. Then, of course, you've got your X-ray generator. You've got your generation, you've got your high voltage tank, your amplifiers, everything connected. Then we go to the console itself, where you have your physical console, and yes, it's a large compute machine, but then it still has the ability to add in. And then, of course, you've got the gantry, so your positioning. Again, a CT, rotating tube, 3 times a second, rotating at several thousand pounds. Lots of things can go wrong. How are we monitoring that? Putting that all together is where we put together our digital twin. And this is really the part I said it's customized to what you as an individual would have. How many scans are you running? How long is your tube warm up? How long are you having patient scans before the next one is being done? These are all taken into account. And what we found, and this is again more of a lab test environment, if we look at our systems which have this versus our systems which don't, we've found that, first of all, with implementing the CT on-watch predict, we could be greater than 99% uptime. Now, depending on your contracts, they have anywhere from like a 90% to 98%. If this is helping us theoretically get 99%, that's obviously utopia for us and for you. The downtime saved here is talking about elapsed time. We looked at over 2,000 systems. I believe like last year, these slides will be available for you to even download, but definitely take photos and we'll take questions as well. Is from the time an error occurs on CT, monitoring more than just the tube now, how many hours were typically did it take versus now how long will it take? So yes, the parts are not sitting there. Yes, someone might have to physically install it. But if we're able to save 36 elapsed hours, that's huge. So how can we do that? And if it's not just looking at your tube, your error could be related to your table, Your error could be related to the collimator blades not opening. There's multiple things we're able to monitor. And then lastly, the unplanned downtime here, we were finding based on situations where there's no predictive services at all, 58% reduction. And the 58% and the 36 hours go hand in hand. And this was based on a study across systems in the US and across Europe, over 2,000 units we had. Now, what's the customer experience? And how does it make sense to you individually? That's what we're going to go through now. So in a typical break-fix environment, the error occurs and you're on the phone. Now, the key point here is the error is occurring because someone noticed it. Now, hopefully it's not a hard down situation. It might be an image artifact. It might be patient banding. It might be some type of phantom image coming in the corner. And you get the call in biomed. It's 5 p.m. on a Friday. You're getting ready to go home. Now you're asked to call up the vendor for this. So system down, people are not happy. What would you do then? You call in. The customer complaints converted to a service record. Someone, if it's 5 p.m. Friday, they might not look at it immediately, but you get contacted back after the service record gets documented. They start asking for troubleshooting. If you don't have remote access, we're pulling the data logs. We're then sending an engineer after a game plan's created with the parts to ideally fix it. And then hopefully after one visit, maybe a little bit more, you're actually remediating it. But this is unplanned. The unplanned downtime is huge. And the problem is that your patients have been rescheduled. Your revenue is being impacted. So all of these, starting from multiple frustrations from your clinician side, your business manager, your department manager, everyone down. Versus the world where we're working in now, and this is the important point I'll just keep mentioning because it's hard to get my head wrapped around it the first time. An error is occurring, but no clinician has noticed it. You're not seeing any patient banding. Your system is up. Yet we're predicting with TubeWatch, for example, at least 3 days in advance, sometimes 3 weeks in advance. We've got indications this tube is going down. The way it's being run at site A is different than site B. We're not just measuring the number of scans being done or patient scan minutes, scan seconds. But we're saying with 95% probability, this tube is going to go down within maybe as less as 3 days. We're going to work with you on finding a solution. So system's not down yet, but an automated notification was generated here. System not impacted. Record was created automatically. Game plan was created, and ideally the system connected, of course, otherwise you don't get the automated notification. The game plan's created with our remote service engineer and the field engineer, and the parts are sent and dispatched. And then the on-site remediation is now happening frequently in one visit, but then they're coming in when you as an individual say, yes, we can get you in between 12 and 1 o'clock to do your first diagnosis, and yes, you need time to set it up, and at 4 o'clock, you can have the system for 4 hours. And we're going to share another example about this, but the key here is the system never went down. Your patients were not impacted. Your patient flow was not impacted. And this is, again, the world of being in a planned downtime environment. So the proactive part replacement, just to iterate, and then we'll go through a live example. The predictive trigger is what's important. And again, with this, you need to have your secure system connection. You need to have your system connected. You need to have the capabilities ready. And how it implements for an in-house organization where you're doing the first watch versus a full service is a little different. We can talk through that as well. Then the remote experts are key here. For us, the advantage is that we obviously have engineers covering every hospital around the nation. However, you don't have every expert in every case, every place, right? So this is where our remote service engineering team, and we've got, I believe at last count, probably close to 400 or 500 of them out there, who are many of them working from home offices, who are taking the information, monitoring the alerts, working with then the field engineers on a game plan, and then going through the example, going through the resolution. Then working with the customer on the notification. Now, I'm going to do Tim, is it okay if I ask you a question? So I'm on the phone with Tim. I see an error occur. Tim, I know your system's going to go down in 3 days. I'd like to work with you on that. What's your first reaction going to be?
My first reaction is going to be look at the schedule and see what I've got scheduled first.
So Tim said, my first reaction is going to be, I'm going to look at my schedule, see what I've got scheduled first. So Tim's already in, okay, I've got to react to this mode. And Tim, maybe because I've warmed him up to this, knows that we have predictive services. But if Tim didn't know this, he's, again, going to be sketchy, saying, why are you doing this? And if I'm an in-house organization where you've got to buy the tube from me, it's like, okay, you're trying to make me buy a tube from you. That's a clinical response. The engineer would say, okay, let's find a solution. But this human interaction is important. How do you know to trust it? How do you know that the data is real? This is really the practical part of implementation we want to share to get everyone comfortable with it. And then with that, of course, you get that field engineer visiting Tim. Maybe it's not the tube. Maybe it's part of the tank. Maybe it's a collimator. Maybe it's a calibration setting. But then also working with you remotely that, hey, Tim, this is something your team's got. You know how to run the calibrations. Let us know when it's ready, and we'll make sure it works. But this human interaction is important. Now, maybe Tim isn't there at the phone. Maybe he was on vacation, and someone else got it who wasn't in the presentation learning about this. That reaction could be different also. So this is where that partnership becomes so important, that your organization knows what the capability is. And we'll walk you through a real-life example of it, of what happened. So this is based on a case which occurred, and obviously we're keeping the customer name shielded here. But at 4:23 in the morning, we found a predictive trigger was received. Now, why was 4:23? Maybe it's one of those sites that's running 20 hours a day. Maybe it's a time zone thing. But it came in, and roughly 7 o'clock, it got analyzed by someone. It's given in the queue, and so any of the remote engineers can see it, and they saw this alert came in. About an hour later, they said, okay, we think it's real. It's a true positive, and we've got a game plan we'd like to work on. They then connected with the customer and talked to them about scheduling. So like the interaction I had with Tim, which was a little bit more congenial than what happens, we found in our dozen customers we found out, we talked to the engineers, they said it was a panic attack they got. The person said, what? Oh no, I'm going to get in trouble. I have to call my manager. I have to call the CEO. I have to do this. I have to do that. So our engineers were calling in thinking, Tim's going to be happy, whereas the person they got like almost was in shock, is like, no, please, not now. I mean, I can't handle this. So that is where we had to talk them down, say, system is still functioning. You have at least a few days, minimum 3 days, could be a little bit more, but let's work with you on a solution. Now, this happened to be a full-service customer, so yes, we had the parts being covered. Yes, we had the ability to work with them. They worked out that the next day, the field engineer with the part came on site. So it takes time to get the parts, make sure they're available. They were there. In this specific case, the field engineer and the biomed met. And then when they went on site, they noticed actually that it was not just a single point failure, it was multiple, but they had the parts that they were there. But I'm sorry, they needed to order an additional part. But again, system's still functioning, but the resolution was require more than one. So they scheduled the install. And then this case, it happened to be the field engineer came on site 11:30 at night. Now, this must have been in the contract coverage, or they worked out that this is the best time for us to do it. And the engineer probably got home really tired because 4 a.m. system was restored. But in this whole time that this happened, customer, patients were not impacted. Your clinicians didn't have to bother. I mean, we already have enough worries about patients not showing up on time. You don't want to have to reschedule them. None of that happened here in this case. And then during the whole time, during the working hours of this case, the parts were replaced during the system downtime, and the scannings were not impacted. Customers, patients were not impacted. It was a win-win. But again, we thought it was a flash that, okay, this didn't work. But when we checked with about, as I said, a dozen field engineers, 10 of the 12 said that first call was horrible. We didn't know how to handle it. So now we're working with our engineers on what is the talk track, how do we let customers know, and in advance we're going to need to make sure we keep spreading this message through forums like this, that this technology is working, that call is not a bad call, it's a call of something could happen. So I was talking with a colleague of what does it mean. It's like I know you're about to get ill. Let's work with you. But that, as a human, we know it's like, no, I don't want to know I'm about to be ill. That's not going to happen, right? So those are the areas we'd like to think things are going here, and the direction that we're taking the industry as well. But this is the partnership we really want to have, and make sure that we keep pushing it there. Now, we've talked with some other OEMs who are not direct competitors, even invited them to be here today, but talked to them about this is where the industry is going. I mean, and how is this, the questions that came up were, how is it impacting an ultrasound versus a patient monitor? And yes, that is all going to happen. Some of them don't have the compute power of a CT or an MR, but yes, the same technology and remote capability is what's getting us there. And if there's a customer site that thinks, no, it's not secure, this has all the same TLS 1.3, 1.2 type of protections. It has all the smarts in it as we would have in larger equipment. But the biggest thing is conveying to customers, and this happened with some customers in Japan. They thought that our lower end ultrasound was less secure, not worth connecting, whereas it's absolutely as important to connect for all some of these reasons there. So that's our presentation for today. I have with me my colleague Chris Clawson, who works closely with many customers, in-house organizations, as well as full service on what's there, to take any questions. And really, as the last few times we've done this, the dialogue and the nature of questions has been what's most powerful for us. So thank you for your time, and open any questions.
Okay, thank you. Oh, hang on. Okay, can you hear me? Okay, good. Thank you, gentlemen, and welcome, Jean-Michel.
Thank you for the welcome.
Hello. We have got some questions.
Hey.
We have got some questions coming. Okay, so the first question is, in your opinion, why aren't more hospitals using predictive analytics in their day-to-day operations?
I'm sorry, could you repeat the question, Linda? It wasn't very clear, sorry.
Sorry, it is, in your opinion, why aren't more hospitals using predictive analytics in their day-to-day operations?
Got it, thank you. Maybe I'll take that one first. So that's a really good question, thank you. In fact, we're at a tipping point here where we're moving from people not even knowing that predictive analytics exist to acknowledging they exist and then adding it now into equipment selection. Even at the AIME show in June this year, we had a number of sessions where customers, large named customers, were sharing their best practices on how to evaluate equipment contracts, and this has been part of it. So I would answer that question saying, we're not using it enough because people aren't aware, and then we're not using it enough because we don't trust is going down. But thank you for that question. Jean-Michel, anything else to add about why it's not used enough in hospitals today?
I think that, we are experiencing what I'm calling the fourth revolution in the world of IT, introducing predictive services. We are just at the beginning, and it's looking really promising. So I think that we are already embarked into this long journey, but we need then to convince people that this is useful, that it could help them achieve more, improve the workflow, and reduce disruptions.
Okay, so another question that's just come in is, can we trust the algorithms? Are you worried about false positives, which would result in more parts replaced than actually necessary?
Yeah, I could take that one. That's really critical because, that's all about the design of the models that we are working on, so that we do have a clear objective for any of the models that we are developing to have a recall, which is the ability to detect issues on the system with a number which is higher than 80%, and to ensure that we do have the right precision when it comes that we have an alert, so that we are not generating alerts for nothing. And again, our target is to be above 80%. So it's a very simple rules. get 80% of the issues and get 80% into the precision when we're getting an alert.
Perfect. And so what can the HTM community do to get attention of healthcare leaders about the importance of predictive analytics?
So I'll maybe start that one, Jean-Michel, and then you can take it from there. So I think as part of, and almost as similar to the first question of why is it not used enough, it's really driving awareness, but beyond just the awareness, showing the actual benefit in dollar signs. And the way we think it makes most sense to look at the dollar signs is how many hours are your systems going down and how many fewer hours would they go down if you had a predictive alert. There's a quantifiable number for that. It could be the numbers of patients that have to be diverted or rescheduled. It could also be that when you don't have a predictive alert, you have to make an urgent purchase where you pay premium for shipment, pay premium for the part. You don't have enough time to shop around. So quantifying the value in dollar signs that are meaningful to your organization, I think are the best way of getting. And really, it's a matter of HTM community, the biomed clinical managers, department managers, really embracing this and thinking up front and challenging us and other vendors on what can you claim benefits and how to get there. Jean-Michel, your thoughts on what else the HTM community can do to help improve this?
Yeah, I would say that one of the important components when we are activating predictive services in how we could improve the workforce. It means, you know, I know that there are a lot of challenges into the HTM communities in terms of turnover, people leaving, etc. So we could bring, you know, these alerts, which could help to have a better precision and drive effectiveness. So I think that here we're talking about saving hours, and I know that all of the HTM are already busy in all of the hospitals. Huh? So having the ability to prove around numbers which are fully grounded on based on the experience of systems which has been activated under predictive services is also a good way to leverage predictive services to convince leadership.
Thank you. Linda, do we have any other questions?
Yes, we do. We have one here. Do you have data showing how many parts actually failed?
Yes, we have. We do have a pretty good understanding of what parts are failing and what parts are driving most of the unplanned downtime. And this is how we are building models. It means that we don't want to address something which is happening, I would say, twice in the lifespan of the system, okay? We definitely are looking to what components are failing and what are the components driving most of the unplanned downtime so that we are developing models around these data.
And in cases, we're able to share that with customers so they actually see what's going on. Now, obviously, it depends a little bit on the contract type you have. If it's a full service contract where we're going to do the work, you'll see that as well. But if it's an in-house contract, then that awareness is even more important because you're paying for the part and you might even be doing the labor. So that communication and getting into a rhythm, just like you would for any call in for any other problem, is critical.
Perfect. So how can IoT devices help predictive trigger alert? What is AL's role in this point?
Yeah, I would say that I could take that one, Sabih. I would say that it's extremely important that when we are designing product, we are designing product in the mindset of developing AI and predictive services. First of all, because we need to have access to the data. We need to ensure that we do have the right set of sensors installed on the system. What we discovered through the design of the models is that binary output, such as an error log, is not really having the same level of interest than an alphanumerical value, like, I don't know, a current value or a voltage value. And this is really why I would say we are having just the seed of predictive services, because we are currently building with engineering products which are driving or enabling, sorry, this compatibility so that we could really talk about Internet of Things, okay? And it's not a kind of analyzing simply a neural log. It's much more powerful than that, because when you do have all of these values, then you could really, I would say, run artificial intelligence on this data and ensure that you do have the right accuracy of the models.
So, I mean,
Sabih, if you want to add something.
Yes, no, so thank you, Jean-Michel. So when we think about our scanners are not just one sensor on it. I mean, as was shown in one of the previous slides, there's hundreds of what you might call sensors or triggers. So we're really a conglomeration of many, many IoT devices in our system. The key, though, is that we're not triggering off of just one sensor, which might have a binary or a window of values. It's actually a combination of a sensor voltage, maybe a fan talking about temperature, another sensor indicating the room temperature, a third one which is looking at the number of patients, a fourth one maybe looking at the time. It's combining all of those factors together that really help us get there. So the predictive alerts here, which is where the machine data side of the artificial intelligence is where the benefits are coming. So as more and more devices get connected, first of all, as more and more sensors and intelligence are built into that, where we can key off of, and as more and more real life failures happen that we can learn from, we're able to do it. It's an interesting point that some of our brand new equipment doesn't have runtime failures yet. So we have less confidence in those, but the ones that are out a few years longer have that. And that's really where the difference comes in to having those years of tried and true platforms which have incremental improvements on them. Linda, are there any other questions?
Yes, there is another one here. Is this AI integrated to CMMS to get data from it?
Okay. So Jean-Michel, this is one that came in on the chat. Maybe I'll answer first with what I responded, and please do.
You could answer, and I could give an update. Yeah, thank you, Sabih.
Thank you. So thank you for the person who put in this question. So as we responded in the chat during the presentation, the data from the scanners is received through a secure connection, which for GE Healthcare is called Insight. It's based on internet protocols. And that data then goes to our GE Healthcare cloud. Now, the AI algorithms which create the predictive analytics and alerts use the customer-specific data and then the cumulative universe of system data that sits on the cloud to create the alerts for that system, because one person's usage patterns will be different than the next. So we're not actually using CMMS data here. Now we're using various other data sorts, but we're not actually using a CMMS in the case of a CT scanner or an MRI. Jean-Michel, other thoughts to add on that?
Yeah, just one thing to add on top of what you said, Sabih, is that we are using our own database when we are developing the AI learning on our models of what failures we have observed as part of our direct operation to deliver services on site, and are making the correlation of when the system is showing patterns of errors or patterns of data, which are kind of highlighting that this system or this subcomponent is going to fail. So it's really a conjunction of different data sources that we are using when we are developing the model. But when after the model is running on its own, we are only using the system data.
Can you hear me, Sabih, Jean-Michel? Can you hear me?
Yeah, sure.
This is Chris. Maybe one other response to the question about CMMS. I think perhaps you're asking do our alerts flow directly into your CMMS? Can we alert your CMMS directly? Is that what you're asking about? I don't know if the person who asked the question is able to respond to that, but if that's the case, to Sabih and Jean-Michel's point, we're reading these logs internally through our remote team first, and we're making decisions about those errors that are being generated, and deciding if a field action is necessary before contacting you for what would then become something that you would record within your CMMS environment. So we're wanting to make sure that we don't add unnecessary steps into your workflow to respond into a service incident before a remote engineer has actually read those logs and determined if a field action is necessary. So at that point, we would contact you and be able to go through next steps, whether it's an in-house team that you're managing or a GE engineer that will come on site, and then you would document that action in your CMMS, and that's where you would start to see data there that would be relevant to record.
So we can't hear you, Sabih.
Sorry. Thank you, Chris. That the communication flow within an organization after a technical issue has occurred or resolved, both are as important as the technical solution itself. So thank you for that. Linda, are there any other questions that have come in?
Yes, we've got time for one more. This one is, are you considering AI integrations into other medical equipment modalities rather than imaging, such as anesthesia and patient monitoring? And what would the cost impact be from the customer's point of view?
That's a good one. Jean-Michel, would you have insights on that?
Yeah, I think that we are starting with imaging equipment because it's really where we connected. We have system connected for a long time, but we are looking and exploring how we could bring, I would say, other modalities such as ultrasound, and why not medical devices, because we might have the same set of data that we could leverage in order to develop models. Okay, I think that the most important thing is to start with systems which are connected, and systems for which we do have enough set of data so that we could start develop models. And that's really critical. If a system is not connected, then the probability to get it AI compatible or predictive services eligible is going to be very few. So it's really part of the overall strategy of the healthcare to develop products coming in the future or already on the field, which are bringing this set of data available for further analysis and development of models.
So if I would add, in ultrasound, we do have some of these capabilities. An ultrasound failure obviously is different in the nature of what might happen in the CT or MRI, but simple ones such as, and it's kind of uncanny, but some of the failures are the hard disk is full. Someone hasn't backed up the data. But alerting you in advance of that before you do a large cine image acquisition, which could take up a large amount of data, is important. So yes, those types of things we can do. Now, what's the value of that versus the tube which goes down is arguable. And then in the patient devices, some of the insights we have, which are on anesthesia gas management, you can't say it's necessarily a predictive alert on the repair side, but there's other capabilities. But for sure, we're starting this way. We're testing our algorithms, making sure that we have the processes, which are as important as the technology there. But there's more to come, as Jean-Michel mentioned.
Sabih, if I might, with regard to the comment or this phrasing around cost and how cost will be impacted, what we've noticed with our customers that are evaluating these solutions in their environment from a cost perspective is really changes when we bring into the discussion or in the evaluation a total cost or a total revenue impact or a total patient impact to the equation. And when you're thinking about the return on potential cost you would pay for a solution like this, if you evaluate that a la carte without an understanding of, to Sabih's last point around what will be the actual impact in potential savings to your organization, even how much would I have to pay if I don't have a solution like this to get someone to come out unexpectedly, or to have someone come out on a weekend. And certainly depending on the device, you're going to pay more or less for those unplanned services. But really, organizations who are beginning to think about these total cost and impact to patient and revenue loss and a larger cost impact to their organization are really finding more value in these solutions and quantifying them in a way that makes sense to their ultimate leadership that's planning technology and looking at, overall patient impact as a part of their metrics of success.
Thank you, Chris. That's a key point. The customer angle here is key.
Perfect.
Linda, do we have any others?
No, we haven't. We're actually coming up to our time. So I'd like to thank you, gentlemen, for your time and for such an informative presentation today. Thank you. I'd like to encourage everyone to visit GE Healthcare's website to learn more about the services they provide to the industry. So please visit gehealthcare.com/services. Now, just a quick reminder, you can obtain your C certificate by completing the post-webinar survey, which will be emailed 1 hour after the completion of today's webinar. You must complete the survey to receive your 1C credit from the ACI, and you'll be able to download the certificate directly from your computer once the survey is submitted. If you have any questions, you can reach us at webinar@mdpublishing.com. Now, if you've missed any of our past webinars, including any by GE Healthcare, please visit webinarwednesday.live to view our whole webinar archive. We'll be back next week with another webinar, so visit webinarwednesday.live for more details and complimentary registration. So thank you all once again for your time today, and I hope you enjoy the rest of your day.
Thank you, Linda. Thank you, team.
Thank you. Thank you. Bye-bye.
Thank you.